The gameplay mechanics for this game aren't very complicated, but I would say it can get a little tricky, so I'll try and break it down and keep it simple. In the last video, we talked about the player controller, where there was a firing mechanism that would fire a basic weapon. And so once that basic weapon is fired, we've got to instantiate the prefab. That's this right here, this basic weapon. It's just the sprite renderer from that pack we downloaded, and I think we tinted it green so we could separate the player weapon from the enemy weapon. So let's open this up and take a look at the flow graph we have for this prefab. First, it does a couple of things. It's going to get a speed variable, which is a graph variable set currently to 6. It's going to go into a vector2 set node. You can set it manually with using the 6, 0 coordinates, or you can do a new x by a variable, which is what I decided to do here, just so I could adjust it at gameplay so I could see what I liked better. And I landed on 6 as a number. From that node, you want to set the rigid body 2D velocity to its new coordinates, which is going to basically plug that 6 into that coordinate and then move it across the map, basically. So it looks like it's firing. And then we want to set a delay of a deactivate timer, which I have set to 3.5 seconds. So this is basically the time it takes for that particle to deactivate itself. Otherwise it would go on forever and then make the garbage collector work harder before it actually just destroys itself. That's all that does. So it just instantiates this prefab and moves it from left to right across the map. Very simple. And then this piece of code here, this says on collision enter, we are going to compare tags. That's that game object compare tag. And we're going to use the tag player. If this bullet basically collides with anything that's not the player, it's going to destroy itself and play an impact sound. So if I had other obstacles in the game or there were anything else, it would effectively hit the target and destroy itself. So off the false node of that branch, we're going to instantiate an impact scene variable. And that scene variable is a particle system. So it's going to instantiate that impact at its self position. So it's going to get the position of self, which is the bullet in this case. And again, the quaternion, we can just use a quaternion get right here because it doesn't matter. It's a 2D game, so it's not going to spin or rotate. And then off that instantiate, we're simply going to destroy self. So either way, this particle is going to get destroyed and will not live on forever and will keep the game relatively small. That's the player bullet. So you notice the player bullet flow graphs don't actually destroy the target they hit. That's handled on the target themselves. So that's how the player fires the weapon. We go back to our prefabs folder, we can see we'll cover the enemy ship for now, and then we'll do the enemy weapon with similar mechanics. This is, again, just it's actually the same model. I just tinted it a different color so it would make sense as it was flying across the map. I didn't have time on this project to make them different colors. They're all the same color, and so be it, and that's okay. Now in this one, like the player gun, I gave the player 2 guns. I gave the enemy 1 gun. It fires from the middle, and that's all it does. And again, that just stores that position. And so in this flow graph, all this does, this is the entire flow graph for the enemy prefab. On the update, it's going to set the position of enemy gun barrel. That's it. So it's just going to grab enemy gun barrel, which is a scene variable, and the scene variable is going to just store the vector 2. So the enemy ship, actually let's look at both of these together. So this is kind of a weird way to do it. I did it this way because I was planning on having more than one weapon to fire. So on the update, again, that's a coroutine. You can tell because those 2 green arrows on the right-hand side. And if you click on it and look in the graph inspector, you can see that it is set to a coroutine. It's going to wait 0.2 of a second and then trigger the custom argument for shoot, which is right below it. And now, again, I did this because I didn't know how many weapons I would be able to shoot. In this case, it's only 1. So if you're thinking, well, why don't you just run the 1 shoot at 2.4 second delay on the update? You could do it that way. You certainly could. But in this case, it does trigger that custom argument called shoot, which is in the next. So off of the custom argument for shoot, we're going to run a once node, meaning because I'm calling this every 0.2 of a second, I only want to do this once. And since they're both coroutines that are both going to continue to do math, so that way they don't shoot all of the time. So off the once node, we're going to instantiate the enemy weapon. Again, the enemy weapon is what handles its movement from left to right and does the explosions. We're going to set its position to the enemy gun barrel, which is updating every frame, and the quaternion, we just get it and plug it in. We're going to play a one shot with the audio source of the weapon effect I downloaded, which is a pew pew. Then off the one shot, we plug that into a delay, a wait of 2.4 seconds. And then this is where we reset the once node. So we take that executable off the wait and we drag that all the way back up to the reset section of the once node. So every 2.4 seconds, we're eligible basically to fire a weapon again, even though we're calling it every 0.2 of a second. If we call that in between shoots, it shouldn't do anything. Yeah, let's go ahead and cover this one now. So this is a pretty wide graph right here. here that I made for blowing up and generating score points. So on collision, we're going to check and see if the tag is a bullet. If the tag is the bullet, which is what the player weapon is tagged as, then we're going to run that into a branch, and if it's true, then we're going to play a sound effect, and we're going to run the explode custom argument. If true, we're going to trigger a custom argument called explode on the sound effects game object. So it's going to play that sound effect for us, and then it's going to destroy self. And once we've destroyed our self, we're going to go ahead and set our score. Now, at the time, I thought I would have a different way of scoring this. In other words, you might have a level score and a total score. So I do have two scores in here. One's an application and one's a scene variable. They do the same thing. You could do this with one variable if you wanted to. It certainly wouldn't hurt. So we're just going to get the score variable, add 7 to it, and plug it into the new score variable. So we're going to get and set and add 7 to it. It just repeats twice in a row because that's what I was thinking at the time. It's that simple. And then the last thing we want to do as far as like movement goes is to move this across the level. So as soon as the start function is called here, which again is a coroutine, off the start event, we're going to set a vector 2 of the speed, right, which is -5, negative because it goes right to left. We're going to set that rigid body velocity, and then we're going to do a delay again to deactivate the game object. And once that deactivate timer goes off, it's going to destroy the game object. Now this is just to keep the enemy ship itself from flying off the level and going on into infinity. So both the enemy bullet, which flies faster so it destroys sooner, and the enemy ship also destroy themselves to keep them from cluttering up the game. And then the last thing we have is if we run into the player. So the enemy ship has to spawn its weapon, basically shoot its weapon across the screen. If the weapon hits the player dies. If the ship hits the player also dies. And that's what we're handling here. Very similar flow machine on collision 2D enter. Going to compare tags to the player. If it's true, then we're going to run that explosion sound effect and then destroy itself. And then this is where, if you notice, we're not destroying the player anywhere in these flow machines. That's handled on the player prefab. So here's the flow machine for the enemy weapon. It looks a lot like the player weapon, doesn't it? So on the event start, it's going to get the speed variable, which is a graph variable. Could have made it scene, but I made it graph. Either way, it doesn't matter. Now this speed here is a -6 because I want it to move from right to left across the map. I'm going to plug that into a rigid body 2D velocity and into a wait node, and which will deactivate after a certain number of seconds, in this case 4. Now it's important to note that in order for these wait nodes to fire, the start event has to be a coroutine. So you can do that by checking this box here, and it will be a coroutine allowing things like time, have it not deactivate right away, and also not go on and on forever. And then again, we're going to, on the collision enter, we're going to compare tags to, okay, if it's a player, if it's true this time, then we're still going to instantiate the impact scene object. Again, it's the same thing. We're going to get the self. We're going to destroy itself being the bullet. And that's how we handle those two things for the enemy weapon and the enemy. One thing we didn't cover in the controller is that when the player gets hit, we in fact blow up. So what we do is on collision enter, we're going to check the tag to see if it's an enemy ship. So if you run into an enemy ship, we are going to also blow up. And what that's going to do is off the true branch, it's going to play an explosion sound effect. Now I did the same thing here. I grabbed a scene variable called sound effects, and I linked that to the audio source game object. I could have put the game object right here in the flow machine. It doesn't really matter. But if you do it this way, then you can just reference a single node instead of have to grab the game object every time. Whichever's easier for you is fine. And then we're going to play the particle system for player dead, which is probably the same exact thing. Oh, it's impact 2 particle system. You can see it over there in the flow machine. The particle system pack I downloaded came with 2. That's really as simple as it gets. We're going to destroy itself, which is the player this time, and we're going to check and see if we have clones. We're going to take our number of clones, which is basically lives. It's not any different, but the theme of the game jam was clones, so I cleverly called them clones, and we're going to subtract 1. And this is where it gets a little clever, because if clones is greater than 0, then we can keep going. If not, we're going to set is dead and pause the game with a timescale set to 0. If it's true, in other words, if we still have lives, we're going to instantiate a player prefab at a very specific position. So it's -9.200. That's going to be that left center side of the map. And we need to get the quaternion right. And I was plugging away at numbers until I got it. So that quaternion angle axis worked at -270 for the angle, and then the axis was 00270. It's just what worked. And then we want to double check that the tag is set to player. So I just added that game object set tag to player. And that's the last part of the player flow graph, to make sure that if the player runs into an enemy ship, they get blown up. And if you look at the enemy weapon, it's also tagged as enemy ship over there. So I tagged them both with the same tag, so I didn't have to go back and do that twice. So if the player collides with anything tagged enemy ship, the player will blow up. And then the last thing we want to do is look at our ship spawner. Now this ship spawner I have here, this is a parent object. So we go to the platform, which is where our code lives. This is where the ships will spawn. And if we look at this flow graph, it's pretty simple. So on the update, we're going to run that into a branch, and we're going to check and see if the level end variable is still false. In other words, the level has not ended yet. If that's false, we run that into a once node. Again, off the once node, we run into a set vector 2, but this time we're going to get a random range between -5.2 and 5.2, and we're going to plug this into the Y, so that way they can spawn anywhere top to bottom. And we don't know where that's going to be. It's going to be a random value. And then we run that into an instantiate node, which we're going to grab the enemy ship, and we're going to take its position from the new set vector 2 position we just generated. The quaternion angle axis that worked for me was -90 for the angle and 0090 for the axis. Again, I played with that in variables of 45 until it looked right. And then off the instantiate node, we plug that into a wait node of 1 second. So every second a ship is going to spawn. And then what you can't see, let me move this up just a touch so we can see how that flows. Off the end of the wait node, we plug that into the reset node for the once. We plug that into the reset portion of the once node, allowing this whole thing to happen again. Game mechanics can get pretty intense. You can take a look at the racing game mechanics I have here that I made, where there were a lot more variables I had to account for and a lot more player choices, which got a lot more complicated. So we want to check that one out too. But thanks so much for watching. See you next time.